In section 4.3, we're looking at the law of cosines, which can also be used for all triangles. It originates from the Pythagorean theorem, a squared plus b squared equals c squared, but what we then tag on here is a little bit of trigonometry that says, well, this can work for anything. So we have minus 2ab times cosine c, where a is side A, B, that's side C, and then here's side C and here's angle C. And the critical thing when we're looking at law of cosines is that we have angle C and side C opposite one another. Because there's some scenarios where we're going to be looking for the side and we have to use law of cosines. If we're in a side, 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 now we're looking for an angle, and we have to make sure that whatever our angle C is, that side C is opposite that. We could also write this in terms of A and B. We could say that side A squared would be equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. Or we could say in terms of B squared, so side B and then angle B. Now this would be A squared plus C squared minus 2 times A times C times the cosine of angle B. But as long as we're paying attention to this side being opposite the angle, then we'll be able to set things up appropriately. So in this example here, we're looking for side C. Given this angle, side C is opposite, so as I set this up, I have C squared is equal to, and it doesn't make a difference which one we say is A or B because we're doing the same thing to both. We have 2 squared plus 3 squared minus 2 times 3 times the cosine of angle C, which is 60 degrees. Now in this scenario, we can plug that whole thing into our calculator. So we have 2 squared plus 3 squared minus 2 times 3 times the cosine of 60 degrees. So that's what C squared is 7. C squared equals 7, which means C is equal to the square root of 7. Alright, easy enough when we're looking for a side. But if we're looking for angle A, it's a little different problem. So let's see, if we're going to say here's angle A that we're looking for, then again, opposite that is the side we really have to pay attention to. So as we set this up, we're going to say 2 squared is equal to, now remember we just found C to be square root of 7, so now we have 3 squared plus square root of 7 squared, just going to write that in as 7, minus 2 times 3 times the square root of 7 times the cosine of angle A. And now we're solving for angle A. Now order of operations, we're multiplying all the way across here, but then we have subtraction, so we can't just combine all these things. We have to keep this together, and then we can simplify here. So 2 squared is 4 is equal to 9 plus 7 minus 2 times 3, so we could write that as 6 square root 7 times the cosine of angle A. These we can combine, 16, and then subtract that over to the other side. So as we subtract the 16 from both sides, we end up with negative 12 is equal to, that sign goes here, so it's negative 6 square root 7 times the cosine of angle A. That's an important step right there, is to make sure that you combine this, move this over, and all this stays together. Now we're going to divide both sides by negative 6 square root 7. Remember, we're solving for angle A here. Divide by negative 6 square root 7. It's going to be critical how we plug this into the calculator at this point. So we have a negative and a negative, so I'm going to forget that, say it's positive. But we have 12 divided by, I'm going to put this whole thing in parentheses, 6 square root 7. So that closes the parentheses for the radical. That closes it for the bottom of my fraction. So I end up with a decimal value, which is what we should have, and it should be in between negative 1 and 1. Because if we're going to take the cosine of an angle, it's going to have to be in between those two values. So now we have the cosine of angle A is equal to this decimal we just found, 0.7559. So then that means if I take the inverse cosine of my answer, then we can find the angle So we just found that angle A is about 40.9 degrees. So a lot more steps when solving for an angle. Now we can, at this point, use law of sines to find angle B. Or if we want for practice, let's go through, set this up, do the same thing for angle B, and then we'll check our work. So now in checking your work, remember it's critical how we set this up. If we're solving for angle B, we're taking the cosine of angle B. That means the side opposite that, 3, has to be on this side. Then we have our side of 2 and square root of 7 in this place, and 2 and square root of 7 here. So as we solve, remember we can combine here and subtract that over so we get negative 2, but order of operations keeps all this together. Then we divide, get our decimal value, take the inverse cosine, and we find our angle to be 79.1 degrees. For this example, we're given triangle ABC and we're given all 3 sides and asked to find the measure of angle A. We would not be able to use law of sines to be able to solve this problem. Here's an example of a problem that we would have to use law of cosines to be able to solve. So now set this up and solve for angle A. Okay, remember when setting this up, if we're looking for angle A, then opposite is side A, and that has to go in this position. So we have 8 squared is equal to 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of angle A. So our angle A and our side A are opposite each other. And now we solve. Got the work from the calculator there to show all the steps.